Thank you for having me. As you know, this is slightly internal, so I'm trying to give you the sense of what I'm doing these days. Actually, this would be a concrete example of mirror dual partners. As you know, Higgs bundles are studied for a long time, and for my talk, I'm just trying to give you a setup. Let's see the compactor among surface of genus G greater than 1, and let's assume that we are working with moduli space of stable degree D Higgs bundles with two structure groups SL2 and PGL2. Hausel and Thaddeus proved that these two moduli spaces have dual Lagrangian trifibrations over the same affine space B. So what do I mean by dual Lagrangian trifibration? I mean that if we take the affine this affine space with the condition that the spectral cover associated to this alpha is smooth, then the fiber of Q would be the fiber of Q at alpha would be the fiber of P at alpha dual as abelian varieties. I mean, this would be the space of all topologically trivial line bundles over fiber of P. And as a consequence, this two moduli spaces have equal E polynomials. So this E polynomial is a polynomial with two variables, and the coefficients are mixed Hodge numbers of these two spaces. And this ST means that we are, since this moduli space is orbital, we are computing the string G E polynomial on the right-hand side. And this conjecture, which was proved a few years ago for arbitrary rank vector bundles and arbitrary genus G curves, has motivated us to study a new moduli space consisting of triples. So let's fix two line bundles, L1 and L2 over C, such that their tensor product is the canonical bundle of the curve. We can consider the moduli space of triples E, phi1 and phi2. As you know, E would be a rank 2 vector bundle, and the phi i's are endomorphisms twisted by these two line bundles, and they commute with each other. Now we want to study the moduli space of Higgs triples for the structure group SL2 and PGL2. And we guess that these two moduli spaces are also S-Weiser partner. So by S-Weiser partner, I mean that exactly the property of having dual Lagrangian fibration over affine space. And my first observations is that the moduli A for the moduli space of SL2 Higgs triples has -1 shifted symplectic structure. So it has a D-critical structure. It means that it is locally, it can be covered by critical locus of regular functions over a smooth variety. And so by critical charts, if we take this form of critical charts, and then there would be a Donaldson-Thomas shift over this moduli space, and which is actually defined by the action of the vanishing cycle functor over the constant shift, but it has homological shifting and tail twist also. And we just try to study this moduli space case by case. Let's take the first step is the trivial case. L1 would be the canonical bundle, and the other one would be trivial. And in this case, we observe that the underlying scheme structure of these moduli spaces are this moduli space is isomorphic with schema structure of the Hitchin space. So by N, I mean the moduli space of Higgs bundles. And for the next observation, we assume that assume that the degree of L2 is negative. In this case, we are working with we assume that phi2 is a meromorphic Higgs field, and then this moduli space, SL2 moduli space of Higgs triples would be isomorphic with the Higgs bundles. I mean, the phi1 would be twisted by OD. And then the Donaldson-Thomas shift would be the constant shift twisted by half of the dimension of the A. And by my computation, I computed that the E polynomial of these two moduli spaces are equal. And yeah, these are my observations so far. I should stop here.